Yes, hi friends. In previous session, we are already discussing about what is the definition for binary search tree and what is the rules that are followed to insert an element into a binary search tree, right? As well as what are the basic operations on a binary search tree, right? So in this session, we are mainly concentrating on operations in detail, right? So here, what is the first operation for binary search tree? Insertion. So what is the main purpose of insertion operation? So by using this operation, we can insert a new node into the binary search tree. So that is the main purpose of insertion operation, right? So here, suppose if I want to insert an element into a binary search tree, some rules and regulations are followed, right? So that can be represented with the help of steps, right? So here, if the tree is empty, then inserted node is a root node. So initially tree is empty, first inserted node becomes root node, right? So that is the first rule. If the inserted node is a less value when compared to root node, then inserted node is placed at left subtree of root node, right? So what is the next rule? If the inserted node is a greater value when compared to root node, then inserted node is placed at right subtree. So these are the some steps are followed before inserting an element into a binary search tree, right? So here I am taking one example for binary search tree. So in previous session we are already constructing this binary search tree based on some elements, right? So here, for suppose in this tree I want to insert node 29, 19, 10, 4, right? First of all, I am inserting node 29 into the tree. First of all, we are checking if the tree is empty or not. So tree is already existed. So that's why this node cannot be considered as a root node. What is the next step? If the inserted node is a less value when compared to root node, then we can place it at left subtree. Otherwise, we can place it at right subtree, right? So here, 29 is compared to root. It is a greater value. Obviously, it can be placed at right subtree. So again, here, what is the right subtree? This is the right subtree. For this right subtree, what is the root node? 18, right? So 18, when compared to 18, 29 is greater element. So that's why we can place it at rightmost position of the right subtree, right? So rightmost position is not vacant. So that's why this can be considered as one more subtree. So for this subtree, what is the root node? 20. So when compared to 20, 29 is greater value. So that's why we can place it at rightmost position of this right subtree. For this subtree, rightmost position is already filled. So that's why we can consider one more subtree. For this subtree, root node is 21. So 21 is compared to 29, right? So it is obviously greater than 21. So that's why we can place it at rightmost position for this subtree. For this subtree, rightmost position is vacant position. So that's why here I am placing 29. So once position is not vacant, apply the comparison procedure recursively for each and every subtree until we can find out the desired position for particular element, right? So here, what is the next inserted element? 19. So first of all, we are comparing root node to inserted node. So 19. So 19 is greater than 14, right? So 19 is greater than 14. So obviously we can place that right subtree. So for right subtree, what is the root? 18. So when compared to 18, 19 is greater element. Obviously we can place that right most position of the right subtree. So for this right position is not vacant. So again it can be considered as root. So when compared to 20, 19 is less value. So that's why we can place leftmost position of the right subtree. So leftmost position is vacant. So that's why we can place it. This position 90. So when compared to 18, this is greater value. When compared to 20, this is less value. So property is satisfied, right? So when compared to 14, this is greater value. So that's why you can place it right subtree. Fine. So then what is the next inserted node? 10. So 10. So 10 is compared to root node. It is obviously less value. So that's why we can place that left subtree. So in left subtree, what is the root? 5. When compared to 5, this is greater value. So that's why we can place that rightmost position. So what is the rightmost position? This one. So 6 is already filled. So that's why position is not vacant. So that's why we can compare 6 to 10. 10 is greater value. So compulsory we can place that rightmost position for this subtree, right? So that's why here I am placing 10, right? So here when compared to 6, this is greater, rightmost position. When compared to 5, this is greater. That's why we can place that rightmost position of this subtree, right? When compared to 14, this is less value. So that's why we can place that left subtree. Fine. So then what is the next inserted element? 4. So 4 is compared to 14. This is less value. So that's why we can place that left subtree. What is the root for left subtree? 5. So when compared to 5, this is less value. So that's why we can place that leftmost position. So leftmost position is already filled by 2. So that's why we can apply comparison procedure to 2. So when compared to 2, this is greater value. So that's why we can place that rightmost position. Rightmost position is already filled by 3. So that's why we are applying comparison procedure 3 to 4. When compared to 3 to 4, this is greater value. So that's why we can place that rightmost position of the right subtree. So here I am placing at node 4. So here I am placing node 4. So when compared to 3, this is greater value, rightmost position. When compared to 2, this is greater value, rightmost position. When compared to 5, this is less value. So that's why left subtree. When compared to 14, this is less value. We can place that left subtree. Right? Now this is about insertion operation. First of all, we can check inserted element is the first node. Obviously, it can be considered as a root. Otherwise, we can apply comparison procedure in between root to inserted node. So if the inserted node is less value, obviously it can be placed at left subtree. Otherwise, we can place at right subtree. So less value is inserted value when compared to root, that can be placed at left subtree. Otherwise, we can place it at right subtree. So this is about insertion operation. Right? If you have any doubts regarding to this session, please post your doubts in comment section. Thank you.